Paul's desk hunting.
Hey. Alrighty. We can give it maybe a minute more. Give folks a chance to join. Jake, you're on the agenda first. Is that okay?
Sounds good. Yep, that works for me.
Hope everybody had a happy and safe end of year and New Year's celebration.
Excellent. So happy to be back.
I had 25 consecutive days away from work, and that was a quality break.
Yeah, that's once you get past 2 weeks, like
you don't want to come back.
Yeah.
It's long enough for you to be like, I'm retired now, right? Like,
yeah, it's like, this is what it's going to be like. I'm good with this.
All right, it's 2 past, so I think we can go ahead and get started. Welcome everybody to the January 14th, 2020 meeting of Kubernetes SIG Multicluster. So first on the agenda today is Jake is going to give us a demo of RASI. And before we get started, I'll just say that if you have a demo that you would like to give, please don't hesitate to reach out or just put it onto the agenda. I'm hoping that we can get a demo per meeting, basically. So the agenda is world writable. Don't hesitate. All right, it's all over you, Jake.
Cool. Oh boy, let's see. I think that I am being screwed by yes. I'll be back in like 1 second. I'm getting screwed by Mac OS. Hold on 1 sec.
Okay.
I'm back again. Let's see if now it will let me share. Yes. Share.
Excellent.
Cool. Am I on Do Not Disturb? Yes. All right, cool. All right. Well, so I'm Jake Kitchener. I'm the lead architect for the IBM Cloud Kubernetes service and Red Hat OpenShift and IBM Cloud. They're two essentially managed Kubernetes offerings from IBM Cloud. Mike McKay is here with me also. He is basically the development lead for RASI in the team. And yeah, I mean, I guess, we've sort of been getting interested in what the community at large is doing from a multi-cluster standpoint. And since we've open sourced RASI, we're definitely interested in getting feedback from others and hearing, more about what would be useful as we kind of move forward in our journey with this open source project. So yeah, I mean, that's basically it in a nutshell. So a little bit about RASI. Basically, there's sort of two core components to it. There's RASI Dash. It's essentially a UI and an API that allows you to basically get visibility into what is running in lots of Kubernetes clusters or OpenShift clusters. And then RASI CD is sort of the counterpart to that actually lets you push new stuff out to those clusters. And we'll get into sort of the details of it, but at a super high level, that's sort of its intention. I think the demo probably does a much better job of helping people understand what the heck it does than me trying to explain it in words. So we'll get to that as quickly as possible. But I guess like a little bit of history of how this thing came to be, like our multi-cluster, I guess, journey. When we originally GA'd IBM Cloud Kubernetes service, we had, I guess, around 13 clusters worldwide that we were responsible for managing microservices on. And it was kind of a disaster because basically nobody had any idea what was running in reality on any cluster at any given point in time. other than to go look at a Jenkins job and try to find the last one that was executed against that particular cluster and what got pushed out there, or like opening up privileged sessions into production systems from laptops and whatever, which is obviously highly discouraged in public cloud, and going and looking to see what the heck was actually there. So, you know, it's necessity is the mother of invention. So we rapidly figured out we needed to figure out some way to easily see what the heck is running everywhere.
Yeah, I think when I first met Kitch 3 years ago, he didn't have any gray hair.
Yeah. And then, you know, we continued to scale. We had, you know, expanded our global footprint. So we had more clusters we wanted to deliver microservices to. And then up until that point, we were like, had a lot of confidence in what we had built with Razzie and some of the power and the tools that it had us. And we'd done a lot of scalability testing and stuff. And so it was at that point in time, we said, hey, you know, so far we're just looking to see what's running on the clusters that belong to the cloud service team. That's where those microservices are running. But we also have all the clusters that we're deploying and managing for our customers. And there's many thousands of those. So we're like, it would be fantastic to help SRE and ops teams to do troubleshooting and manage customer clusters if we had the same level of visibility for those. So we basically enabled it out of the box for every single one of our customer clusters. So, you know, we sort of like said, put our money where our mouth was and said, let's just go for it and scale this thing way up. So initially that was just visibility. And then we sort of got to the same thing where it's like, wow, there's a lot of content that we're deploying into these clusters as part of like the provisioning process for our customers. We could really streamline the release process of those things if we leverage Razzie. And you'll, as I kind of go through the demo, you'll kind of get to see some examples of what those things are. So after much happiness and success in internal use, we said, you know, look, we talk about what we're doing with a lot of our customers and other teams in IBM, and they're all very interested in this thing. Let's build like an open source variant of it. And, you know, basically start pursuing the open source path so that others can have access to this thing. So today that is, you know, there's an open source project, Razzie. The easiest way to get to it is just go to razzie.io and there's links to the GitHub repos and stuff. But it is pretty much like a ground up rewrite of what we use internally, right?
Yeah, I think the problem we had, the internal version we had was so customized and tailored to the way we do things. We had like our namespaces hard coded into cluster fader.
Yeah. So like there's pluses and minuses. Like it forces you to like basically strip out all the nasty hacks and stuff that you've put into your own code that's only ever for you, to make that thing sort of like cleaned up for open source use that's functional beyond just like our specialized environment. So yeah. And we'll talk a little bit more. So we'll go into some of the details of like how we're using it today, what it looks like in our internal use, a little bit more information about how the open source project works and kind of what the future of the open source project is. Yeah.
So I have a question. So is Razzie very similar to Tanzu? I mean, we're not making a comparison, but for me to understand along those lines, a multi-cluster management kind of thing. VMware has this Tanzu called multi-cluster management.
Mm-hmm.
Is Razzie very similar along those lines? But an open source version.
I haven't used the VMware tool, but maybe when we go through the demo, you'll get a better feel for how close it may or may not be.
Okay.
Yeah, a lot of times when we talk about Razzie, it's more or less, it's not necessarily managing the clusters themselves, but it's managing the resources that go in the cluster.
Yeah, that's really what it comes down to. Yeah.
Okay.
So like, we're not trying to manage like provisioning of worker nodes through it or anything like that. It's all about managing the content that's running in those clusters.
It's a day-to operation tool, rather.
Yeah, totally. Yep. You know, we talked about sort of the global footprint. So obviously this was like a huge driver is that I think I remember from the poll that went out, you know, there's a lot of folks that were using multi-cluster for geo distribution, and that's exactly what we're using it for, right? Like we have basically points of presence for the service all over the world, and therefore lots of clusters and lots of stuff to keep managed. I think I'm probably going to do the demo real quick now, and then we can kind of continue talking, because I think it'll give like a better view of what the heck this thing is and what it looks like. So this is basically our internal version of RASI that we're running to manage the service. I demo this because there's a lot more cool stuff to go show you, right, than there is to just do like a little demo open source thing. So I think it gives you a much better feel of like what is capable with RASI versus just like a quick demo. So real quick, like some of this stuff is obviously bespoke to our internal version, right? Like this kind of data would exist inside of an open source RASI implementation. But like these are like views that we've built into the UI that are kind of customized to us, right? Like region names and stuff are not a thing that is sort of like baked into the RASI concepts. It's just data that RASI has that we've built custom views on top of. So we can basically see, cluster counts that we're managing in various regions around the world, and we can kind of see what all the versions of those kube clusters are. They're just like data that we're always curious about, so it's nice to just kind of have it on the front page.
I pretty much got tired of people constantly asking me for these numbers.
Yeah, like I would say like probably about 85% of all the function that exists in this basically comes from somebody showing up at Mike's desk and saying, it would be really great if RASI did this.
Yeah.
And somebody might be me, I'm just saying. So yeah, that's kind of the front page, but I think like the more interesting thing is basically to maybe look at the resource view. So a great example would be Armada API. This is one of the microservices that our team basically uses to run the IKS service itself. And if I go drill in and look at this, I can basically see like, hey, this is all the places around the world in the clusters where Armada API is currently deployed. It tells me like basically what container image it's using. We have some slick stuff, like it has basically like vulnerability scan results that are included here. Like, so this is also part of why this thing demos better when I show you the production thingy than when I show the open sources. Like some of this stuff again is like customized things that we built, like the vulnerability scan integration. It is like the vulnerability scan is stuff that's part of IBM Cloud. So it's not like it couldn't be done in open source. But like typically, I think we sort of incubate stuff internally in our version and then work on getting it out to open source. Yeah.
Yeah, and actually, what we're trying to figure out is, go ahead.
Sorry, I was just going to ask, like, did RASI deploy these things, or is it just monitoring them?
Both.
Yeah, like initially in that timeline, initially all it could do was see all this stuff. And like right now what you're sort of seeing is like the visibility side of it. I'll show you in a minute what it looks like to deploy something using RASI. But yeah, so these particular things are monitored and deployed using RASI.
So basically everything you're seeing here is just kind of the current state of the clusters themselves. So we rely on the cluster itself to be the source of truth on what's actually deployed there.
Yeah.
And what like packaging format does or formats does it support? Like, can you deploy a Helm chart? Can you deploy like what bags of things can you deploy?
Basically anything that could be represented as a kube resource. And today, those are, obviously the primitives like config maps and deployments and stuff like that. But you can also, there's also some CRDs that also allow you to deploy Helm charts with kube resources. There's a Helm chart CRD, but I think Bitnami has it.
Yeah, they have like a Helm operator basically.
Yeah.
Mm-hmm.
So that's kind of our answer for that. Is like, we want RASI to just focus on primitive kube resources, and then we can build on top of that, but it would be through existing CRDs and things like that.
Yeah, and that brings up a good point, right? Like basically what we're doing is we're piggybacking off of some of the logic that sort of exists in add-on manager to do like reconcile. so that, RASI's able to correct for drift. So essentially, like Bob may go log onto a system and start monkeying around with a bunch of resources that were originally deployed with RASI. But if, depending on like what the add-on manager reconciliation flag is set to, like RASI will just overwrite that stuff using the same behaviors and stuff that you get with add-on manager.
Now, that being said, though, it seems like every day someone's asking about Helm and can we do Helm? So
yeah,
I imagine someday we'll probably support Helm.
I mean, somebody could go contribute it to the open source community if they wanted to, right?
Yes,
It's like another resource type, but it's like, as you said, like there's plenty of other things out there that will do deployment of Helm charts, and then you could just use RASI to deploy the CRDs that would tell that thing to go apply it.
When we get a little more of the technical talk about what a remote resource is, I think you'll get a better understanding of how you could actually support things like that.
For sure. But I think like for simplicity's sake at this point, just like if it's YAML, we'll apply it basically.
Okay.
But I think some other interesting things to point out here. So like you'll see version, and you'll also see LD version, which is launched darkly. So I think part of the secret sauce of how our implementation of this works is that we use Launch Darkly as a component behind the scenes to distribute like rules information to all the clusters about what should be applied. And we'll talk more about this when we talk about the future. Like it's what we're using now because that's kind of what we got started with. But we've kind of realized that it's probably not a dependency that everybody wants to deal with. And like we have like these remote resource concepts that we'll talk more about, but it's just not very much fun without something that can sort of like do some sort of like rules engine pub sub stuff. And so that's some of the things that we're working on going forward in the community, and we'll get into the details of that. So I think my suggestion to you for right now is to just like ignore the Launch Darkly version. It's essentially like, think of it as this is what was the desired state set for that cluster, and then the version is what the actual state is.
Independent change too.
Yeah, and then I think the other really cool thing, and this was definitely one of those things where like I wandered over to Mike and said like it would be really cool if I could see like a history of what got deployed when, and like what the change was.
Yeah, and then I think our operations manager took that one step further and said, "Can you tell me what was deployed on these clusters on April 1st, 2019?"
Yeah, so you can give it like a date, and it will tell you what was the change history for that date, kind of thing. The other cool thing is that all these things are commit hashes, and does the open source version do the same commit voodoo to get back to like a Git repo or no?
It does, but it does it better.
Okay.
Because, and here we just kind of rely on some naming standards, like you have to tag the images with a GitHub commit hash. The new version, you just add an annotation to your resources, and then we'll pick up that special annotation and put it as the version here. So you can put a link to, it could be back to GitHub, it could be back to Bitbucket, it could be back to your laptop's FTP drive or whatever.
Yeah, but like it's just nice to have it in the dashboard. Like if you're going and debugging a problem and you're like, oh crap, something broke earlier today. What got deployed? 4 days ago we went from this commit to this commit. Well, let's go see.
Click on arrow. Actually,
you can like bring up the diff, and you can basically just go see directly like, hey, these are the changes that were made as part of that push. Which is really nice for debug. It's like just from like an operational standpoint, it was pretty life-changing to have this kind of data. Even before we could do changes with it, just to be able to see all that stuff was pretty amazing. Right, so that is basically giving you a view of like deployments essentially in this case, right? Now, the cool thing is, like, let's say I wanted to go push out a change for this particular microservice. So this is where kind of the rules come into play. So basically, if you look through here, you'll see there's rules that say, like, cluster name starts with, or, like, region of cluster equals this. So basically, like, metadata starts with blah, 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 whatever, something that you define. And then you can basically select, like, what build or commit or whatever you want to call it, what version you want to have deployed out to that thing. So like if it's DevMex and I'm like, oh, I want to go roll out a new version of this thing, I can basically pick the new commit and I can request a change. More Voodoo is like we have like integration with our change management system that's not an open source. So like essentially you say like, okay, I'm gonna push out this change. You click start, and then it basically tells you like, hey, this thing is waiting to be approved. In this case, it's auto approved. There was no change management. And then if I click start deploy, then it'll actually push out that change, to that cluster.
Yeah.
Do you want to talk about what it actually means to like push a change?
Right. So this is so what this means is that we actually don't go out to any cluster when we do the start deploy. All we're doing is we're updating the rule and launch directly, and any cluster that matches that rule. In this case, any cluster whose name starts with devmex 01 carry 5 will automatically pick up the change and apply it. So this could be 1, 10, or 1,000 clusters, and they'll actually all pick it up at the same time,
right?
And apply. And the cool thing about this, so I think someone asked on the call just a second ago, like, what does the UI show? The UI typically won't update until the clusters actually apply, gotten the rule update, apply the new, or download the new YAML resource from Cloud Object Storage, apply that resource, and then kind of sent the information about what's running that cluster back to the dashboard here. Typically that takes about 60 seconds on average.
It's pretty fast.
So most of our deployments, our average are just, go ahead, request a change, wait a few seconds, and then see it show up in the dashboard. It's been deployed. So,
right.
And anything that.
So this sounds like a pull model rather than a push model.
It is
Definitely, and that's kind of like the secret sauce we have here for RASI is that we adopting this pull model. It's really allowed us to scale because I think Jake mentioned before when we had 13 clusters, we have a hard time just pushing out content just to 13 clusters. Let alone thousands of clusters or even just 25.
Yeah, so like a good example of how this really benefits us at scale is like if I go back out to the main dashboard and whatever, I've got 9,114 version clusters out there, and if there's a CVE that gets released and there's a fix for 114 in we don't use this to do the master side components that we manage for customers, but like, let's say that there was a CVE in like Kube Dashboard, right? Which is like an add-on that we manage through this for customers, or like in Calico, stuff that's running in customer clusters. Like if there's an update, like CVE comes out for Calico, we would basically, build the fix for that, push it out to our object storage as like, basically this is like a new version of Calico that's available. And then we would just change the rule that says like, hey, if you're a 114 Kube cluster, you should go from Calico 3.8.1 to 3.8.2. And then automatically every cluster, all 9,000 of those clusters will go pull down the 3.8.2 version and update themselves with the latest version.
There's typically we don't go out to all like 9,000 clusters at once. There's some kind of cool magic like in the launch directly, which says like, hey, go out to 25% of these, or go to 5% and 50%. Right,
but like once you've like sort of done your canary, you can basically just say like whack it out to everything essentially. So yeah, like running a Jenkins job that has to go do like a kube control applied in 9,000 clusters would not go well.
Or 9,000 Jenkins jobs, which is kind of what we're headed down.
Either doesn't matter how you slice and dice that thing, it just ends badly.
Yep.
So yeah, it is pull model.
And the cool thing about the process is it goes forward and backward, obviously. So since we're applying kube resources, if you apply something and it doesn't work for some reason, rolling it back to the previous version takes the same amount of time.
Yeah. Yep. Exactly.
So in terms of time, like let's try to wrap this up by the hour.
Okay.
One thing that I was wondering as we're talking about this is there like a community meeting or a community Slack people can join if they want to find out more about contributing? Like, how do people contribute to RASI?
So RASI.io, there's actually a Slack link in there for a Slack channel that we have. It's part of the IBM Kubernetes Service Slack instance. Get started there. Any issues you want to open, pull requests are obviously always accepted. But yeah, like get shown here, the connect with us with Slack should get you started there. Now, as far as community meetings go, this is kind of part of like the maturing process we are doing. So some of the things that we're moving on to next is one is our goal for this year is to help mature and put better processes around the open source project.
Yeah. So Yeah, that's it. I think probably in the last couple of minutes, we'll talk a little bit about kind of the future of the open source project. So as I mentioned, like today, like a lot of the magic is sort of done through Launch Darkly. But what we're working on right now in the community version is this idea of channels and subscriptions, which is basically like there's an API on Razzie now that allows you to publish new channels, and you can publish versions to those channels, and then you can create subscriptions to them for specific clusters that meet like a specific set of requirements through tags, essentially. So it's like it gives us the vast majority of the power that we have today with Launch Darkly, but without having to have all of Launch Darkly as a dependency there. So I think that's kind of like the future of this thing. I don't know, Mike, timelines for some of that stuff. I mean, we're sort of monkeying around with it internally now, but
Yeah, I mean, I think we're thinking first quarter to have a working solution on there.
Right.
And kind of what Jake was mentioning there, it's like today the Razzie components, I mean, you can do what we've showing in terms of like the pull-based deployments and things like that, except it's just a lot more effort because you have to kind of manually set up your object storage buckets, push stuff there manually, and this is going to help automate that and make it easier.
Yep. All right. Any other questions in the last few minutes here? All right. Well, like I said, I'm at Kitch on Slack, on basically the community Kubernetes Slack. If you have questions, or like I said, if you go to razzie.io, there is a link out to our own sort of like bespoke Slack for the service and the open source project.
There's specifically a Razzie channel on that.
Yeah, there's a Razzie channel there. So if if you start digging in and you have questions or comments or feedback, that's a great place to get in touch with us.
Yep.
All right. Well, thanks a lot for the demo. Appreciate it.
Yep.
Thanks.
So next on the agenda, we've got a few things about KubeFed. The first one is probably pretty quick. We have not had any agenda items for the KubeFed working group in quite a while. I sent out, well, we had a thread on the mailing list about folding KubeFed working group meeting into the main SIG Multicluster meeting, at least for the time being. And I did not see anybody object to that on the mailing list, but I'm also not sure that everybody checks the mailing list very regularly. So wondered if anybody had opinions about that they would like to share. That's an open question to the room.
I mean, in my opinion, it makes sense if there is not too much activity and the meetings are not happening. So, yeah.
Now, Hector, I think you had a couple other agenda items related to KubeFed. If there's no more comments about working group, we can just go right into those. All right, I think you've got the floor, Hector.
All right. Yeah. So yeah, well, so I'm working for D2IQ, also known as Mesosphere in the past, still yet. So basically, we are using KubeFed for one of our core components, which is platforms that allow to deploy multi-clusters across multiple providers and create federations and stuff. So for us, KubeFed is this it's kind of a core component, and we were seeing that there were not much activity. We kind of opened a couple of PRs and one got merged, but it seems that there are no active reviewers or active maintainers based on the response time of issues or response time of PR. So we were offering ourselves, in this case, myself, to help to maintain the repository, to help to I don't know, take care of issues and stuff, because it's one of the core pieces of our platform, one of our products. So yeah, we we want to keep using it. We want to keep improving it. So that's it. And yeah, we wanted to use this meeting to make it more public.
Yeah, I think I'm definitely interested in the offer of help. I personally have not had time to devote to KubeFed lately, so maybe Hector, you and I can have like an offline conversation later today or tomorrow about like the specifics. But I'm definitely interested if people want to help maintain KubeFed to facilitate that. Now, I think you also had a PR that you were interested in getting merged too. Is that right?
Yeah. So, I mean, the PR, I understand that it won't be released soon, or at least until there is some traction on that. Is basically the creation, but yeah, the PR is using aggregate roles instead of just having to create a specific role per tool and stuff. So we are using aggregate role for Kubernetes, and I was
like the cluster role aggregation.
Exactly. So
yeah. Okay.
So that adds to the default Kubernetes standard roles permissions to also touch the KubeFed resources. So that's what it does. That seems to be pass. A couple of weeks ago, I saw it was failing, but it wasn't really to my changes. So I also think the Pro LCI might need some love as well. And yeah, so I'm here to help her to contribute in any way.
Okay. I definitely don't want you to be blocked by a PR that's hanging. So let's talk about that offline when we talk and figure out what the best way is for that to get merged and to move forward.
Sounds good.
Sound good?
Yeah.
Okay. So I think that is everything on the agenda for today. Does anybody have anything they want to just raise with the group while we're here? Or you can get some time back. All right, sounds like that's it for today. Thanks a lot for joining, everybody. Thanks for the demo, Jake, appreciate it. And I'll just remind everybody, if you've got a demo that you'd like to give, don't hesitate to reach out. I'm P. Mori on Kubernetes Slack, or the agenda is just world writable, so you can put something in there, and I'll see everybody then in 2 weeks. All right, Thanks. Take care, everybody. Bye.